Alkanes. Refining crude oil. Petroleum is mixture of alkane hydrocarbons. Petroleum fraction has mixture of hydrocarbons with similar chain length and boiling point ranges. Fractional distillation, key points. Oils heated, then passed into a column. Fractions condense at different heights and temperature of the columns decreases upwards. Separate based on their boiling point, and boiling point is based the size of the molecule, so larger molecules have larger van der Waals forces. Similar molecules condense together, and small molecule condense at the top at lower temperature, but bigger molecule condense at the bottom at higher temperatures. Split weak van der Waals forces between molecules for this process. Vacuum distillation unit. Heavy residue from fractionating column is distilled again under a vacuum, and lower pressure over liquid lowers its boiling point. Vacuum distillation means heavier fractions are separated again without high temperature, which can break them down. Fractional distillation in laboratory. 1. Heat flax with Bunsen burner or electric mantle. 2. Vapors of components in mixture to be made are formed. 3. Vapor passes through fractionating column. 4. Vapor of substance with lower boiling point reaches the top of the fractionating column first. 5. Thermometer used to measure temperature below volatile substances' boiling point. 6. Vapors with higher boiling points condense back into flask. 7. Only most volatile vapor passes into condenser. 8. Condenser cools vapors and condenses to liquid and is collected. Fractional distillation used to separate liquids with similar boiling points. Cracking. Cracking converts large hydrocarbons to smaller hydrocarbons by breaking carbon-carbon bonds. Alkanes cracked into alkenes and alkanes and hydrogen. Economic reasons for cracking. Shorter carbon chains are in more demand than larger fractions. There's excess large hydrocarbons, and to supply demand for shorter ones, longer hydrocarbons are cracked. Products of cracking are more valuable than starting material. Need high temperature to split strong covalent bonds. 2 types of cracking: thermal and catalytic cracking. 1. Thermal cracking. This happens at high pressure and temperature. Makes alkenes, alkanes, and sometimes produces hydrogen used in Haber proofs. Bonds break in molecule, so carbon-carbon bond fission and carbon-hydrogen bond fission. 2. Catalytic cracking. Happens at middle pressure, high temperature, and with catalyst called zeolite. Makes branched, cyclic alkanes, and aromatic hydrocarbons. Used to make motor fuel, and branched, cyclic hydrocarbon burn cleanly and used to give fuels high octane number, which means fuel burns smoothly. Cheaper than thermal cracking because it saves energy as lower temperature and pressure are used. Combustion. Fuel releases heat energy when burnt. Alkanes readily burn in presence of oxygen. Combustion of alkanes is exothermic. This is why they're used as fuels. Complete combustion happens when there's excess oxygen. Products are carbon dioxide and water. Incomplete combustion. Limited oxygen, then incomplete combustion happens producing carbon monoxide and carbon and always water. Incomplete combustion makes less energy per mole than complete combustion. Carbon causes global dimming and reflects UV light from sun. Pollution from combustion. Sulfur is an impurity found in the fractions that forms sulfur dioxide when burns. Coal has a lot of sulfur, and lots of sulfur dioxide is emitted from power stations. Sulfur dioxide dissolves in the atmosphere's water and makes acid rain. Sulfur dioxide removed from waste gases in furnaces by flue gas desulfurization. Gas passes through scrubber that has basic calcium oxide, which reacts with acidic sulfur dioxide to do a neutralization reaction and produce used in plasterboards. Sulfur dioxide and calcium oxide forms calcium sulfite. Nitrogen oxides. Nitrogen oxides made by reacting nitrogen and oxygen in a car engine. High temperature and sparks in the engine gives energy to break strong nitrogen bonds. To form nitrogen monoxide or nitrogen dioxide. Catalytic converters. This removes carbon monoxide and nitrogen dioxide, an unburned hydrocarbon from exhaust gas, and turns them into harmless carbon dioxide, water, and nitrogen. Converters have ceramic honeycomb coat with thin layer of catalyst metals like platinum, palladium, and rhodium to give large surface area. Global warming. Carbon dioxide, methane, and water vapor are all greenhouse gases. Water is main greenhouse gas, and then it's carbon dioxide and methane. The greenhouse gas, UV wavelength radiation, passes through atmosphere to Earth's surface and heats up Earth's surface. Earth radiates out infrared long wavelength radiation. Carbon dioxide bonds absorb the infrared radiation, so infrared radiation doesn't escape from atmosphere. This energy is transferred to other molecule in atmosphere by collisions, so atmosphere is warmed. Carbon dioxide levels have increased because increased burning of fossil fuels. Earth is getting warmer because of increased levels of greenhouse gases in atmosphere. Synthesis of halogenoalkanes. In UV light, alkanes react with chlorine to form mixture of products with halogens substituting hydrocarbon atoms. Alkanes don't react with a lot of reagents because carbon-carbon bond and carbon-hydrogen bond are strong. The mechanism is called free radical substitution and turns alkanes into halogenoalkanes. Free radical substitution consists of 3 steps: initiation, propagation, and termination. Initiation. UV light gives energy to break carbon-chlorine bond because it's the weakest bond compared to the others. This bond is broken in homolytic fission. Chlorine forms 2 chlorine radicals. So, each atom gets 1 electron from the covalent bond. Bond breaks to form 2 free radicals that don't have a charge but do have a dot to represent the electron. Free radicals are reactive species that has an unpaired electron. Propagation. Chlorine free radical is free reactive and remove hydrogen from methane, leaving methyl free radical. Methyl free radical reacts with chlorine molecule to make main products and a chlorine free radical. Propagation step forms free radical and product. Chlorine free radical regenerated, so it can react with more alkane molecules in chain reaction. Termination. Collision of 2 free radicals doesn't make more free radicals as chain is terminated. Minor step leads to impurities of ethane in product and right using structural formula. Propagation step when halogens in the middle carbon. If question asks for halogen to be substituted onto middle carbon in chain, it's important to put free radical, which has a dot, on certain carbon in propagation step. Further substitutions can happen where CH3Cl to CH2Cl2 to CHCl3 to CCl4. Overall reaction equation for formation of CCl4 from CH4 and Cl2. Overall reaction equation for formation of CFCl3 from CH3F and Cl2.